This is Breaking Analysis with Dave Vellante.
At AMD's Advancing AI event, Lisa Su called her shot, kind of like Babe Ruth. The question now is whether AMD has built the engineering machine to hit it. Now, last week in our Breaking Analysis, we argued that AMD's next reinvention, it didn't require AMD to beat NVIDIA head-to-head. Rather, we said that the company needed to become what we called the indispensable second platform in a huge and rapidly expanding AI infrastructure market. Now, that thesis was well received by our community. We got a lot of really good feedback on it, but at Advancing AI, Lisa Su raised the stakes considerably. They didn't present products like Venice and Instinct, the MI455X, Helios, and Rockham as respectable alternatives. It rather claimed outright leadership across CPUs, GPUs, rack scale performance, memory capacity, network bandwidth, and tokens per dollar. And it extended the argument across enterprise AI into physical AI, like robotics, ultra low latency inference, and a rapidly expanding partner ecosystem. Now, the obvious narrative coming out of the event was whether or not AMD's model of open co-innovation could match NVIDIA's extreme co-design. And we initially, on theCUBE, framed the debate that same way ourselves. But we now believe that's really only a surface level argument. In fact, we think the real race is what we're calling engineering velocity, i.e., which organization can turn silicon, software, development infrastructure, automated validation, and customer feedback, as well as increasingly AI-assisted engineering into the fastest, continuously improving platform. Now, in this breaking analysis, we're going to compare those two organizational models. We're going to define the emerging, what we call the engineering factory. We're going to examine the technical evidence that was surfaced this weekend by SemiAnalysis. Then we're going to quantify AMD's network partner strategy. And we're going to separate benchmark claims from production reality and focus on what people should really be thinking about and assess whether Helios can convert Lisa Su's ambition into sustained customer outcomes and business value. Because in AI infrastructure, the winner may not be the company with the best benchmark on a keynote day. It's probably unlikely. It's probably going to be the company whose engineering systems learn, validates, and improves the entire platform faster than anyone else. So let's double down and double click on this premise and sharpen it up a little bit. So last week, our view was that AMD, as we said, didn't have to beat NVIDIA, it just had to become this indispensable second platform in a market that's huge. The TAM is multiple trillions. Lisa Su had it at, I think, 1.4 trillion by 2030, and it's growing, so fast, and certainly fast enough and large enough to support more than one company. But at Advancing AI, Lisa Su, effectively took that ambition that we put forth and raised it well beyond our framing. AMD claimed leadership across its entire portfolio: CPUs, GPUs, rack scale systems, memory capacity, network bandwidth, tokens per dollar. So the obvious debate coming out of the event was whether AMD's model of open co-innovation could match extreme co-design. And again, we framed it that way on theCUBE, but now we believe this is much more of a surface level argument. A deep technical analysis from SemiAnalysis helped expose something deeper and got us thinking. Their work argues that AMD's software progress is substantive and real, but that the limiting factor is increasingly not engineering talent. It's really the engineering infrastructure, meaning stable internal GPU clusters and the access to those, continuous integration, automated validation, and enough testing capacity to support a rapidly expanding number of AI coding agents. Now, SemiAnalysis deserves credit for identifying that operational constraint, but we think the observation points to a much larger and strategic competitive dimension. The real race, in our view, is what we're calling engineering velocity. Now, as we're saying here, engineering velocity is not a third strategy. It's complementary to extreme co-design and open innovation. It is really the competitive outcome for which both organizational models, AMD and NVIDIA, are attempting to optimize. NVIDIA pursues it through extreme co-design. Extreme co-design is a tightly integrated engineering system with deep, serious control by NVIDIA across silicon, software, networking, and systems. AMD is pursuing the same outcome, in our view, through what they call open co-innovation. This is a networked engineering system which spans its own teams, and also a curated group of customers and partners, and of course, open source communities. So the deeper question is not which philosophy is better, or even who wins a benchmark war and benchmarking on keynote day. Rather, it's which organization can learn, validate, and improve the entire platform faster and turn that advantage into a flywheel that creates production outcomes that create business value. That is the prism that we're going to look through in this breaking analysis. So let's just start by comparing the two organizational models. So we've established the premise. Let's now, double click on the different approaches. So NVIDIA operates what we would describe, as you see here, as an integrated engineering system. Its extreme co-design model brings together, as we well know, silicon, software like CUDA and all the CUDA libraries, and increasingly open source models like Nemotron, and then of course networking through the Mellanox acquisition, and then Spectrum X, scale up, scale across, scale out, scale across, interconnects, systems, and of course rack scale. The rack scale architecture takes all of this, including co-packaged optics, into a tightly coordinated roadmap. Now, NVIDIA works with manufacturing partners like TSM and ecosystem partners, storage ecosystem, software ecosystem. The big news a couple of weeks ago was with Palantir, et cetera. They work with many companies, Snowflake, Databricks, et cetera. But of course, it retains an unusually strong control in its hand over the architecture and the points of integration. This is their fundamental philosophy. It's a first principle, allowing them to accelerate faster than Moore's law. Now, that control can reduce coordination latency across the ecosystem. Hardware and software teams can optimize against the common design target. They can validate changes across the stack and make trade-offs within one tightly managed engineering system. Now, AMD, as we're showing on the right-hand side, they're pursuing a different model. We describe it as a networked engineering system. AMD, of course, still owns the core assets like EPYC and Instinct, and it drives ROCm. It acquired Pensando for networking and the Helios architecture. But it is deliberately bringing customers, partners, and open source communities into the development process. So we heard at Advancing AI, Meta, and we had Meta on theCUBE, contributes workload and networking requirements. OpenAI and Anthropic are contributing frontier model experience and requirements. NeoClouds, in particular TensorWave, which is an AMD-only NeoCloud, they contribute operational feedback. And then open standards widen the number of participants that can influence and improve the platform. And so that, in theory, creates potential advantages, specifically more sources of insight, broader workload exposure, and potentially greater ecosystem adaptability. But it also, of course, creates a coordination challenge. So a networked engineering model only really works when the interfaces are clear, the software composes reliably and predictably and consistently, and the responsibilities are well understood, and that customer feedback has to move rapidly back into the product. So this is not an argument that open is inherently better than proprietary. That's not the point, nor is the point that integration is inherently better than collaboration. These are just two different organizational models, and they're pursuing the same objective, i.e., engineering velocity. So the real question that we're asking in this break-in analysis is not which philosophy sounds more appealing, gives marketing advantage. Leave that to the vendors. What operators we think should care about is which model can learn faster, validate more accurately, and continuously improve the entire AI platform at the highest sustained rate, because that's where you're going to get business value. And that raises the next obvious question. What actually determines engineering velocity? Engineering velocity. And the answer, in our view, is the quality of the engineering factory behind the platform. So let's dig into the engineering factory. If engineering velocity is the outcome, the mechanism behind what we call the engineering factory is the mainspring of that outcome, let's define it a little bit in a little bit more detail. By engineering velocity, we mean an organization's ability to continuously improve its AI platform faster than its competitors, not just by writing better code, but by combining software development, access to hardware, really important, automated testing, validation, customer feedback, and increasingly, as we said earlier, AI-assisted engineering into a continuous learning system. Now, this distinction is important to our premise because the CI/CD pipeline alone is not the moat. Rather, the moat is the entire engineering factory surrounding it. Now, what do we mean by that? Well, AI coding agents, they can now generate kernels, they can identify bugs, they can suggest ways to optimize, they can explore a lot more software paths in parallel than human engineering teams could previously attempt. But remember, every one of those changes still has to be compiled. They have to be tested on real hardware. So that hardware has to be available. And the more of it you have, the more you can test, the more your engineering bandwidth will be. So they've got to check code and changes for accuracy. You've got to measure this stuff for performance. You got to run it across different models and different configurations, and then you got to validate it to ensure that the apparent gain in one workload has not introduced, pushed bottlenecks somewhere else in the system. So as AI software generation becomes easier and more plentiful, validation infrastructure becomes more important and maybe less plentiful. And that's something that we're keeping an eye on. This is why a stable internal GPU clusters are, we think, a competitive advantage. And it's why continuous integration and things like merge gating coverage are critical. Merge gating coverage is a software development practice that requires minimum testing thresholds on specific lines or blocks of code, which have been modified in a pull request before those changes are allowed into a production level feature branch of the code. And it's why the time required to support a newly released model is so vital. And it's also why the speed with which production feedback gets incorporated into the next software release becomes a competitive advantage in our view. Now, you see the metrics on the right-hand side of this chart. They give us a starting point for testing out our thesis here. Let's go through a couple. How quickly does a platform support a new model release? How much of that software stack is continuously tested before the code is merged and deployed? What's the measurable performance improvement that arrives with each new release? How stable is the internal development infrastructure? How quickly are regression deltas detected and fixed? And how effectively does customer experience flow back into product development? Now, we give SemiAnalysis real credit for highlighting the underlying engineering infrastructure issue inside AMD. The SemiAnalysis work suggests that AMD's software talent and software quality have improved quite dramatically. They, at one point, gave AMD like a 0% probability of making any inroads to NVIDIA. Now I'm not sure they're quantifying it, but they're saying it's substantial. But definitely saying their software quality has improved significantly, but they're calling out unstable development clusters and inadequate validation capacity, which can constrain the rate at which those gains can compound. So we believe that observation points to a much broader conclusion, something that's more strategic. The engineering factory, not just any single chip or any rack performance, that's what's becoming a competitive asset. And then in an upcoming slide, we're going to look at 3 SemiAnalysis data points that we think help quantify both AMD's progress and the constraints that they're facing. So let's dig into engineering velocity a little bit and talk about the progress versus some of those constraints and put some data behind the engineering velocity framework that we're putting forth here. As we said, one of the most useful technical analyses that we've seen coming out of advancing AI comes from SemiAnalysis. They wrote a blog post, Can AMD Break the CUDA Moat? It's worth checking out. Their work is valuable here because it's not just an independent source. That's important. In other words, not just vendor marketing. But according to their post, the team there, they use AMD accelerators directly, and they're frequently reporting software bugs. They contribute upstream fixes. They track vLLM and SG Lang, continuous integration alongside model level performance. vLLM and SGLang are two, for those who don't know, they're pretty widely used and respected open source engines that are used to run large language models, very quickly. Now, to be clear, we are not saying that every conclusion that SemiAnalysis put forth in their report is, we're adopting. These figures have not been independently verified, by us or to our knowledge, anyone else. But we'll pay attention to that and keep digging. But three key points are especially relevant. The first is progress. SemiAnalysis reports that AMD delivered as much as an 18x improvement in Kimi K2.5 interactivity in less than 30 days through software changes around ADER and vLLM. ADER stands for AI Tensor Engine for ROCm. It's an open source library created by AMD. Now, just to be clear, this does not mean that ROCm is caught up to CUDA. It does, however, show that AMD's software iteration rate can accelerate dramatically when the hardware and software teams and optimization cycles all line up. The second signal is the 90% gating target shown in the middle here on the right-hand side. According to SemiAnalysis, AMD was working toward at least 90% parity with CUDA on vLLM merge gating tests by the Advancing AI conference. But SemiAnalysis claimed that instability and reassignment of internal development clusters and resources for other priorities disrupted that effort. Here's where we need to step back a little bit and take this in. So look, a passing demo, in other words, a successful live demonstration of a software feature that proves that the code works, you can call that done, but a passing demo also tells us that a workload can run. Okay, great, check. But a merge gating test prevents code from entering the software stack unless it passes correctness and regression testing. So that is how software quality improves over time, rather than, you're constantly fixing bugs and fixing the same bugs or bugs that you saw before are now popping up in future releases. There's a third key point, which is internal capacity. We're showing here as the capacity gap on the right-hand side of this slide at the bottom. SemiAnalysis estimates that even after AMD adds thousands of accelerators to its development environment, the company's stable internal GPU capacity remains more than an order of magnitude below NVIDIA's. Now, again, we can't independently validate that exact comparison. We'll see if AMD responds or if NVIDIA, validates in any way. But the takeaway is, we think, strategically important. AMD may no longer be constrained primarily by the quality of its engineers. It may increasingly be constrained by the scale and stability of the engineering factory that is supporting them. And AI coding agents, of course, they intensify that problem because everything is just done faster and at scale. Because when one engineer can launch many agents in parallel, each generating agent is going to throw off kernels, testing configurations. They're going to propose optimizations. That the volume of code goes through the roof much faster than the capacity required to validate it. So every change needs stable hardware to do regression testing, quality checks, performance validation, and this has to be repeated at scale across multiple models, multiple frameworks, multiple topologies. So the bottom line is this. AMD's software velocity is unquestionably accelerating, but its engineering factory is where we should put the focus. That may limit how quickly those gains can be realized. And here's where it gets interesting. AMD's strategy is not to simply build more internal infrastructure. It's also attempting to extend the engineering factory outward through Meta, OpenAI, Anthropic, TensorWave, and other partners. And this is where the networked engineering model moves from theory into practice and is a key competitive dimension that we think people should watch. So let's talk about the networked engineering model and dig into that a little bit. This is where AMD's open co-innovation story has to go from philosophy to proof that we can actually measure, or at least we can observe. So we'll try to do that. What AMD showed on stage, and we're showing here, are not simply logo relationships. Each partner is contributing a different capability or workload input or operating feedback into the loop, specifically into AMD's networked engineering system. So you see here, Meta is working with AMD on networking, scale up, scale out, and broader system co-design within a partnership framework that's targeting up to 6 gigawatts deployments. The important contribution is not just demand for GPUs. That's great. It'll drive revenue. But Meta is bringing production scale infrastructure requirements into the engineering process. OpenAI is contributing frontier workload requirements, hardware and software optimization, and future system co-design under a deployment framework of up to 6 gigawatts. And so there's serious revenue behind that as well. Anthropic is new. It's a new deal that AMD announced last week. That adds models, standing up models, ROCm input, and also deployment collaboration with plans for up to 2 gigawatts of Helios. And these relationships give AMD direct exposure to the workloads that are going to stress the next generation of AI infrastructure. TensorWave, we had them on theCUBE, we've had them many times. They contribute something different, which is operator learning feedback. Because they're an AMD native cloud and an exclusive AMD Neo cloud, TensorWave, they're qualifying the platform, identifying operational issues, and feeding those lessons back into AMD. CEO Derek Horton said on theCUBE that the company could target 1 to 2 gigawatts of Helios capacity in 2027. Now, Cerebras here is different. It was sort of a sideline here, but it was a little bit of a surprise bringing them on stage because it's not core Helios co-design in the same sense. AMD is using that partnership to fill a workload gap, disaggregated ultra-low latency inference with a joint service that's expected later this year. So think of it as AMD's version of the NVIDIA Grok acquisition, the $20 billion acquisition, and launch of LPX this past March at GTC. This is for ultra-low latency workloads. So the scale of relationships here is significant. But look, we got to be precise. Words matter, so does precision. These are up to commitments. They're targets and they're partnership frameworks. It's not a fully deployed capacity. It's not booked revenue. It's not independently proven platform economics. Some of these arrangements also include substantial financial incentives. In other words, a gigawatt target demonstrates engagement, strategic intent. It does not in and of itself prove demand, economics, or production success. So we need to pay attention to that. What these relationships do show, however, is that AMD is not merely asking customers to consume a finished product. It's opening up the kimono. It's inviting major customers and partners into the engineering process, something that NVIDIA does not seem likely to do, at least not to that extent. Different philosophies, and that's really the promise of a networked engineering model. It creates a differentiated strategy for AMD. It's not simply copying and pasting AMD, although it might seem that way sometimes. But this approach gives them more workload insight, more production feedback, more participants contributing to the learning system, and potentially greater engineering velocity. Of course, the risk is coordination. AMD still has to convert that breadth of participation into software quality, platform integration, the whole validation schemes, and execution speed. And it's got to keep up with NVIDIA and NVIDIA's more mature integrated system. Remember, we said last week, NVIDIA has at least a 15-year lead, and Lisa Su's trying to compress that into 5 years with focused innovation through R&D, filling gaps with M&A, and then building out the ecosystem. And that brings us to the distinction between ambition and real evidence, because partnership scale and keynote claims still have to translate into independently validated production outcomes. So let's dig into that. We'll talk about claims and then how to make them credible and what kinds of things to focus on. AMD did not make subtle claims at advancing AI. The company said Helios would deliver roughly 15% more compute, 50% more HBM capacity, and 50% more scale-out bandwidth, and up to 30% more tokens per dollar than NVIDIA's Vera Rubin platform. Those are pretty significant claims, but they require some digging and some interpretation. As we understand the methodology, AMD combined its own specifications, measurements, and modeling with publicly available information about NVIDIA's Vera Rubin system. which is in, I think, limited release. And that doesn't make the analysis invalid, but it does mean that these are not yet equivalent to independently reproduced side-by-side production tests on commercially deployed systems. I asked AMD's Sony Giandani directly about the benchmark methodology because comparisons this aggressive are naturally going to attract attention. They certainly got my attention, and they deserve scrutiny. So let's take a look. Please play the clip.
I'm going to push you on those benchmarks. Where do these benchmarks come from? Let's dig into that. I'm seeing all these claims. I was like, wow, they're not pulling any punches here. So, okay, are they based on published specs? So you got a Vera Rubin somewhere, or I don't know about? Is it how are you?
There must be a Vera Rubin for us to contrast and compare these benchmarks, and for us to put up on stage. As Lisa mentioned, she put qualifiers on all the tests that were conducted per benchmark, and these are all open models.
Yep.
People that have access to Helios will be able to run those same benchmarks. So there wasn't much detail left out in my mind in terms of the benchmarks that we published.
So look, my takeaway, I'm not saying that AMD exaggerated its results, nor is it that NVIDIA has somehow disproved them. Neither of those has taken place. So despite Sony Giandani's response, the honest answer is that we don't yet have sufficient independent evidence to declare a production winner. AMD presented highly ambitious engineering claims and supported by its own internal benchmarks against NVIDIA's published product specifications. Observers would be wise to assess workload assumptions behind those, and will be interested in NVIDIA's own internal analysis and response once it gets a hold of AMD's products. Regardless, the most important proof will be independent validation on real workloads and ultimately in production experiences. And this breaking analysis, or any of our analysis for that matter, they do not rise or fall on keynote claims and vendor benchmark numbers. Engineering claims deserve engineering evidence. Specs establish the potential. Benchmarks, solidify a claim, and production really establishes the truth. And that's kind of the ultimate measure. What matters here is whether Helios delivers sustained performance, software maturity, high utilization, operational reliability, and compelling economics when customers deploy it at scale. We know the challenges of these large, heavy, novel racks. We saw it certainly with GB200 racks, and we expect that AMD is going to face similar challenges, and this connects directly back to engineering velocity. Look, AMD, no question, pulled a strong move at advancing AI by claiming Top Gun at event across their entire portfolio. Okay, that's nice, but it's really not the main issue. What really matters is whether AMD can learn from production, repair its defects, improve software, incorporate customer feedback, and make Helios significantly better with every subsequent release. Because the benchmark debate is ultimately going to be settled in operating environments in the real world, not on keynote slides. And that's why execution becomes the ultimate test. Helios is simply the first proving ground for whether AMD's network engineering model can convert its ambition into repeatable production outcomes. So because execution is the ultimate test, let's dig into that a little bit, because engineering velocity only matters if it can be translated into customer success and business value. AMD's already cleared several important hurdles in our view. The architecture is defined, so that's super important. The silicon is coming into focus. The portfolio is expanded dramatically. I mean, even into physical AI, and Xilinx gives them that flexibility. As we said last week, AMD has compressed, and I said earlier today, 15-year NVIDIA lead into 5 years through organic R&D, M&A, and ecosystem expansion. But let's agree that the customer partnerships are substantial. I don't think anybody's taken that away from AMD, and virtually all leading players, this is a really important point, all leading players that we've talked to want an alternative to NVIDIA to keep them honest. They want to improve their negotiating leverage, and they want to secure more supply. And with AMD making these bold claims about performance and economics, many in the industry are going to cheer them on. But this race is just getting started, and AMD has a lot to prove. The production journey, as we know, is filled with danger. There's always icebergs ahead, and it's often unforgiving. A compelling vision has to become an integrated architecture. The architecture needs to survive customer qualification. The benchmarks have to translate into sustained utilization. The software has to become reliable and dependable, and the complete system has to deliver operational excellence, not just once in a controlled environment, but it's got to be repeated across thousands of GPUs and accelerators running these super expensive workloads, and it's got to be doing that for days or weeks at a time. Of course, AMD knows this, but this is where Helios becomes critical, not because this entire analysis depends on one rack design. Helios is just a first in a major proving ground for AMD's networked engineering model, and no doubt they're working on Helios too. We've heard a number of companies working with them in the ecosystem, but the company has to demonstrate that platform integration across EPYC, Instinct, ROCm, networking, and rack scale systems, and it's got to prove software maturity. It's got to prove operational readiness. It's got to prove production reliability. So the ability to absorb those field experiences and improve the platform very quickly once customers begin deploying it at scale is really, really important. TensorWave CEO Derek Horton, he was very candid on this point. According to Horton, TensorWave already has access to Helios, but he described the current period as testing and validation ahead of production. So he acknowledged that there's going to be issues to work through. But he also expressed confidence that AMD has learned from the difficulties associated with the earlier next generation rack scale deployments that we were talking about before across the industry, namely those of NVIDIA. And I think it's a reasonable way to think about it. So the existence of these early problems would not in and of themselves invalidate the architecture. Every new rack scale system introduces new challenges. You got power, cooling, cabling, networking, software, serviceability, weight. The real measure, we think, is how quickly the engineering system detects those problems, identifies the root cause of those problems, and deploys fixes and incorporates the lesson into the next release. That is the idea we're putting forth of engineering velocity in production. And the broader lesson extends well beyond AMD. I mean, we started this breaking analysis with an assessment of Lisa Su's claims at advancing AI, but it's evolved into a much, much larger question about how AI companies compete. The market doesn't care who won the keynote benchmarking debate. It's going to remember which platform delivered reliable production outcomes and which organization learned fastest to improve those outcomes continuously. So execution, not ambition and slideware, determines that credibility. And that leads directly to our action item. How should infrastructure operators and ecosystem partners evaluate platforms when current benchmark leadership may be less important than the demonstrated ability to improve at scale? So let's close where we began. The obvious debate coming out of advancing AI was open co-innovation versus extreme co-design. But we think this is much more than a debate about open versus closed. Look, NVIDIA is going to respond. They already have with its version of open. You got Nemotron open weight models. You got Spectrum X is based on standard protocols. Earlier this week, NVIDIA announced the Open Secure AI Alliance, along with 36 high-profile companies. NVIDIA in this alliance is contributing open models, open weights, open model weights, data, research, a new agent harness, research into the alliance to accelerate the development of these new cybersecurity tools and techniques, which are definitely on top of mind of customers. And so it goes. We're more open than you are. No, you're not. Yes, we are. No, you're not. Whatever. We just have to squint through that. We believe the less obvious and more interesting competitive takeaway is about organizational and ecosystem learning. So NVIDIA and AMD are pursuing engineering velocity through fundamentally different models. NVIDIA's integrated engineering system emphasizes tight architectural control, coordinated roadmaps, and optimization across silicon, software, networking systems. AMD's network engineering system, on the other hand, seeks to expand the learning loop through customers, partners, open standards, and broader ecosystem participation. Neither model wins by definition alone. The winner will be the platform that can learn from production faster, validate changes more rigorously, and repair problems more quickly, and then translate those lessons into sustained improvement across the entire system that drives value for customers. So here's our breaking analysis action item for AI infrastructure operators and ecosystem partners. Over the next 6 to 18 months, Add engineering velocity to your platform qualification evals and use it to determine both where you deploy and where your organization can create differentiated value. If installing Helios in your NeoCloud can drive incremental revenue and customer value and bring sorely needed AI capacity to your customers, that makes a lot of sense. But if you're reselling an AMD Helios, if that means your value add is simply a distribution channel for AMD's new rack, well, depending on your business model and margin goals, that might not be the best fit. Moreover, don't evaluate a platform only by where it sits today. You got to measure how quickly it's improving. You got to look at time to day zero support for important new models. You got to look at the software release cadence, continuous integration and validation coverage. Those are really critical things. Production reliability and utilization, time to detect and resolve failures, the quality of customer code development, and of course, management's record of delivering on their roadmap, that do-say ratio that we talked about last week, which was very high for Lisa Su, for it as well as NVIDIA and Jensen. For infrastructure operators, this means qualifying platforms on current performance and demonstrated rate of improvement. For ecosystem partners, it means choosing the platform where your engineering contribution can create genuine differentiation, not just another channel for reselling the same hardware. And we feel pretty confident in this action item and these recommendations. Strategic optionality still matters, but optionality should not mean spreading resources indiscriminately across every architecture. It means identifying the ecosystem whose engineering systems are improving fast enough to earn deeper qualification, investment by you, and your participation. So the next generation of AI leaders, they're still going to have to build and ship great chips, no doubt about that. But their sustainable and durable and differentiable advantage is going to be defined by the engineering systems they build to make the entire platform, i.e. the silicon, the software, the networking, and operations better, faster than anyone else. In the AI infrastructure era, today's benchmark leader may not prove to be tomorrow's most valuable platform. The fastest learning platform may very well be the more important factor. Thank you for watching. I'm Dave Vellante of theCUBE Research, and this has been Breaking Analysis. We'll see you next time.